Okay, so today we're going to be working with this problem, and just make sure to keep in mind that figure as we go about this problem. So the first part is asking us which way is the electric field going to be between the disk. This is just kind of all my work, just to kind of something to look at. And so in order to find out part A, we have to know that the electric field is going to go from high potential to low potential. We know that VB minus VA is negative 10. So we also know that our electric field is going to follow that path that it's doing, and it's final minus initial. So you know that it's going to end at B and start at A. So we know that it's going to go from A to B, from disk A to disk B. That's going to give us that part A. So the second part is asking us to find possible values of QA and QB and R. So that's what all this work is going to be. And so we're going to start out by trying and find that electric field. And so we know that E is equal to VA minus VB over D. And you can see that's what I did up here. Just kind of plugged all those in. So next, we need to find Q. And so in order to find Q, we know that VA minus VB is equal to 1 over 4 pi epsilon naught times Q over R. So you do those, solve for Q, that's what I'm doing here. And then we're going to move on to E. Remember, keep this equation in mind because we're going to have to plug that in later. And so you're going to start with this one. So now we're going to be looking at that electric field between the disk, and that's going to be given by that equation there. We're going to plug Q in in that equation there, and so then we're going to get a simplified version. Long story short, 4 times VA minus VB over R, and then we're going to solve for R, and then that's what we're doing here. And then solve that, we know that we're going to get 10 volts over 1.0 times 10 to the negative 4th meters. That's what's going to be there. And then so we're going to go back to this equation up here like I mentioned earlier, and plug all that in there, and you're just going to plug and chug and stick it in your calculator. It's always my favorite thing to do, and that's what you're going to get here. And then you're going to get QA and QB. Remember, they're going to be two separate charges, so just beware about which one goes where. We know that QA is going to be 4.4 times 10 to the negative 13th. That's going to be positive, and then the QB is going to be negative of the same magnitude. So we have another question that we're going to be working with, and that is going to be question number 49. And here it's a little bit more difficult, and so this is the question here. And I will put that into the comment section, and then I'll just kind of show you my work as we go along. And so that's going to be our next question that we're going to work with. And so this is my first page of work. It takes quite a bit, so just have patience. And so first we're going to need to find the V of the positive and the vector that's going to be an X. And so that's where we're going to start, and we're going to start by finding R. Find the magnitude of R, find B positive, the potential difference of it being positive, the positive charge there, and then we're going to do the same thing for the negative charge and find the potential difference due to the negative charge of the dipole, and then we're going to need to find that net electric field, which is what we're going to do here. And then that's kind of my pictures to show you how to do that. And that's just a good picture of that whole page there. And then next, we're going to do the same thing, but this is going to be for the Y component of that. So you do the same thing. You got your R over here, and then you R positive, R negative. You want to find the magnitude of both of those. And then you're going to find the potential difference positive, potential difference negative, same thing you're doing there. And then you're going to find the net potential difference at Y, which is going to be 0, because they're all going to cancel. And then, so for 49b, it's asking us what are the approximate values of v at the location, and part A of these locations are far from the dipole. So we're going to assume that the points are far apart. They're going to be approaching infinity. And so that's going to pretty much simplify that, and then you just kind of plug it in there and get that. And so the next one, part C, we're going to be finding the gradient of the potential along the x-axis, and that's what we're doing all here. You're going to use the x component of the electric field due to the dipole on the dipole axis, which is going to be this here. And it's going to simplify to the partial derivative of Vx over the partial derivative of x. And that's what that's going to simplify to. And that's going to show that the negative gradient of the potential along the x-axis is equal to the x component of e to the x. And then for D, we know that along the y-axis, dv over dy is equal to 0, because the potential along the x-axis is 0. So that shows that there is no electric field due to the y-axis.